So our learning goal is still being able to solve a system of linear equations by substitution. But today we're also going to add to that, what do we have to do sometimes, like when one of the equations isn't ready for us to substitute into the other. And then you're also going to be setting up, again, systems of equations to problem solve, and that's how I want you problem solving. So in this particular example up at the top, I'm just going to leave that for you to study on your own. It's like another extra example for you. And we're just going to dive right in and practice together. And make sure that if you need to take a few side notes somewhere about some things that I say, that you do that so that you are going to make your life as easy as possible anyway. So when we are solving by substitution, we on Monday were looking for equations that already had an x or a y by themselves. And was that the case always? Did you ever have any that weren't by themselves, short of the word problems? No, I think I picked problems, that's why they're so random from the practice set. I picked problems that would be the case. Now today I picked problems that you're going to find, wait a minute, these don't have the same behavior as those ones did that I was dealing with in the other lesson, other problems we did in this lesson. So I want you to somehow make a mental note or write it down that when you're solving by substitution, you want to look for a coefficient of 1, a positive 1. We want a positive 1 coefficient on either an x or a y. That's the equation we're going to try and get a variable alone in. We don't want to have to work any harder than necessary. So when one of the equations does not have an x or a y by itself, look for a positive 1 coefficient on one of the x's or one of the y's. Every year I tell students that, and every year I'm amazed at how hard they make the problems for themselves because they just decide, oh, for some random crazy reason, why don't I solve this equation for y, even though that was the one that would have created the most work. So I want you right now to tell me, in this system of equations in number 1, are there any positive 1 coefficients on our x and y terms? No. Okay, how about the first equation? Which variable or variables have a positive 1 coefficient? The x does. We can slip a 1 in there. How about the y in that one? Is that a positive 1?
No.
What is it?
Negative.
That's a negative 1. So no, that does not qualify. It has to be a positive 1. How about the other equation? The y has a positive 1 coefficient. So we really have here two choices. Since neither equation has the x or the y by itself, we can rename one of those equations. It doesn't matter because both of them have a variable that it would be friendly with. So which one do you want to do? Should we do the first one? Okay, let's make this known. Rename first one for x. In other words, since it has a positive 1 coefficient, we want to get that equation solved for x. So we're going to write down x minus y equals negative 3 and get that x alone. What do we have to do? Add a y. Add y to both sides. X is now by itself, and we have negative 3 plus y. Okay, now we have an equation that has a variable by itself. So I want you to put in your notes this also. This is step 1 from above. Because we had our own steps on Monday. We had our own steps on Monday, and we're still going to stick with our own steps of 1, 2, and 3. So we're not numbering this step. We're just going to make this be our first thing we're going to do, if necessary. And then we're going to rewrite our system of equations. Well, we renamed the first one, so we're going to say, okay, the first equation now has this name instead.
And the other equation, we are not going to mess with. So here's our system of equations as we're going to work with it now. Because now it's ready to do step 1, 2, and 3 like we did on Monday. Substitute and solve for one of the variables. Step 2, solve for the other variable. Step 3, write an ordered pair answer. What's going to get circled? Y minus 3 or negative 3 plus y, however you wrote it, okay? If you wrote it y minus 3, then that's the same as negative 3 plus y. What's it going to get substituted into in the other equation? Or in other words, we have to use the other equation now. So let's write it down. Once you circle that expression, that exempts that equation. It can't be used now. We got to use the other equation. And what are we going to substitute into? The x. The x has to be substituted in for because that says x equals. So we're going to have 2 times in parentheses, very important parentheses, what we're replacing x with, and then the rest of the equation is just going to stay like it is. And we're going to solve that equation for y. What do we need to do first, though, before we solve it? Mara?
Distributive property.
We've got to do some distributive property. We got to simplify it. So after our distributive property is done, we have negative 6 plus 2y. Bring along the rest of the equation. Ready to solve now? We got some like terms to combine. We got these guys who can be put together. So we have negative 6 plus 3y equals 12. Now are we ready to solve?
Yes.
Okay, now we can finally solve. Okay, solve that for y, please. Y equals 6. Okay, we get 6 for our y. Let's circle that so we don't lose it. Step 1, we solve for one of the variables. Doesn't matter which one we solve for first. Does that matter? Do we have to solve for x first because it comes first in the ordered pair? No. So now we'll move on to step 2, where step 2 says, okay, now that you know what y is, which equation do you want to use to get x? Now, this is not a check problem. We are solving. So I'm going to say that you can use the first equation's first name, or the first equation's new name, or you can use the second equation, and that one never did get renamed. So we really have 3 choices here. Which one makes the most sense? The new name for the first one, because it says x equals, and that's what we need anyway, so let's use that one. And we're going to sub in 6 for y.
Yes.
And what do we get for x? What do we get? 3. Yes, Connor?
For like when you're renaming the first equation, could you have solved it for y instead of x?
Sure, you could have, but then you would have just had to work harder. You had to do 2 steps of work then.
So y
What is its name in y?
y equals negative x minus 3.
Nope.
Oops, y equals x plus 3.
Yeah. Then you can do that, and then you're going to sub in for y instead of for x then, aren't you?
That's what I did.
Yes. Do you still get the same x and y value we did? Absolutely. So are there lots of different ways to go about these? Yeah. Connor had to work a little harder than we did though, because he first moved the, what had to be moved first? Can't even remember. The x had to be moved first, then you had to divide everything by -1. We only had to do 1 step. Okay, that's all. Okay, step number 3. What do we do in step number 3? Ordered pair, and our ordered pair answer is 3, because that's our x value, x is always first in the ordered pair, 6, because that's our y value, 6 is always the other coordinate in the ordered pair. Now it says check your answers, let's just do some mental math checks. Blake, would you talk us through that, please? Do a mental math check for us. Out loud. No. Anybody else want to do a mental math check out loud for us? X minus y equals -3. That means we got to put 3 in for x and 6 in for y. 3 take away 6, what's that?
-3.
Oh, it checks out on that one. We got to take 2 times the x value, which is 3. 2 times 3, class, is 6. Plus we're supposed to add the y, which is a 6. So 6 plus 6 is 12. 12 equals 12. We appear to have a good answer. Okay. So do you have to do physical check bounds?
No.
No, I'll let you off the hook for that today again. But take the time maybe to do a mental math. Okay, let's go to the back side and try another one. Okay, again, let's make a good decision. Are either of these equations solved for x or y? No. Next thought process would be, do any of the x's or y's have a positive 1 coefficient? No. Well, then what? Well, then try and make your life as easy as possible by solving for the one that will not create fractions, not create, like extra steps. What do you think? Anybody have an idea what might be a good equation to rename and for which variable?
Second,
The second one, what do you want to rename it for, Carter?
x.
X. Okay. Since Carter was brave enough to speak up, we'll let him have his way. Solve second one for x. So that means 4x minus 16y equals 32. No way we're going to make this into a one step because we don't have a positive 1 coefficient. So what's our first step going to be?
Add 16 to both sides.
Add 16y to both sides? I love how you guys just write the 16. Well, 32 plus 16, they can be added together, but can 32 plus 16y really be combined? No, so we're going to write that y there. Okay, so these guys cancel each other out, and we have 32 plus 16y, also known as 16y plus 32. Next, divide every piece by 4. X equals 8 plus 4y. We have accomplished renaming the second equation so that now we can say, okay, our first equation did not get renamed. Our second equation's new name is and the less willing you are to write down stuff, the more confused you'll get and lose track of what's going on and end up with answers that you went through all this work for that won't be right in the end. Okay, what should I circle? Shay? 8 plus 4y. That means I have to use the other equation now to sub into. So I'm just going to, step number 1, I'm just going to write down my other equation right away. And then I know I have to sub in for the x. So I'm going to replace the x expression. It is equal to, in place of that x, carry along all of the rest of the equation. Okay, you got this. Get that solved for y. Get our y value, please. right now on your own, what do you think you're gonna do in step 2? Which equation are you gonna use to get our other variables value? Anybody want to share with me your idea? Shay? The second equation, the 4x minus 16y equals 32? Or its new name? Its new name, yeah, that makes a lot of sense because we need the x value. So since it says x will equal this, let's sub into that one. You agree with me? Okay. And step number 3, what's our ordered pair solution then? 112? 12, 1. Yes, the x value must go first, followed by the y value. So really doing all the same steps we were doing on Monday, it's just that we have to rearrange one of the equations, get it solved for x or for y, make good decisions about which one to get the x or the y alone in. Doesn't mean that you can't get the answer right if you don't make the same decision I do. Just means you're gonna have to work harder probably. Okay, let's go to number 3. We have one word problem we're gonna do here. We have Kate and Joel buying some CDs and DVDs that are used. Again, you know what? Sometimes before you even get too wrapped up in all of the numbers and stuff that's going on, it says, first of all, I think we should underline this. We're supposed to do it by setting up and solving a system of equations. We know other ways to problem solve. I'm not saying that they're wrong, but this is how they're asking us to do it. Well, if we have to set up and solve a system of equations, chances are there's 2 unknowns in here. So let's find out what are the things that are unknown. All I do is I just zero in at the end of the problem where it's saying find or determine or look for or whatever. It says right here, determine the cost of a used CD and a used DVD. Those are unknowns. So how do we start our word problem? By defining the variables, describing what our variables are going to represent. So let's start that way. Let x be, let y be. Mara, what do you want x to be?
You wrote x first.
Well, yeah, I only need it once, don't I? Good catch. Okay. Oh. Okay, come back here. Okay, thank you. What should we let x be, Mara?
UCDs.
Okay, what about the UCDs? How many there are, or what? We're gonna be more specific. The cost, we have to talk about the cost, so we have to be that specific. Let x be the cost of a used CD. It doesn't say determine how many, it says the cost, so we have to make sure we're specific. And then y is the what? Cost of a DVD, of a used DVD. Now, if you don't use the word used in there, that's not a big deal because there aren't new and used in here. Everything in this problem actually is used, so. Okay, well now I'm gonna go back and say, guess what? They're gonna give me some information that's gonna help me set up equations. Kate bought 3 used CDs, 1 used DVD. Her friend Joel bought 2 used CDs and 2 used DVDs at the same store. If Kate spent $20 and Joel spent $22. So we have a whole bunch of information regarding Kate. So I'm thinking she could be one of our equations and Joel could be our other equation. Go ahead, write 2 equations that you think we could use to help us problem solve for the cost of these items. Okay, Kate's equation, anybody want to share their equation for Kate with me, please? Come on. Connor,
Y equals 20 minus 3x.
you worked a lot harder than I would. Anybody else have that same equation? You do, Brady? Did it start out that way? Yeah?
Yeah.
Yeah, and Connor's yours did too? Okay, cool. Anybody, no one else has it, you all like this?
Yeah.
Or did anybody possibly maybe do this? Kate bought 3 used CDs. She bought a used DVD, and altogether she spent $20. Anybody do that? And does that rename match Braden and Connor's equation? It does, okay. How about Joel? Help me out. I'm waiting. Shay?
2x plus 2y equals
Equals what?
22.
Okay. Apparently he bought 2 used CDs and he bought 2 used DVDs and he spent $22. Okay. Braden, what's your equation look like?
2x plus 2y equals 22.
Oh, this time you decided to go with the norm, huh? Fine. You what?
I was too lazy to
Too lazy to rename it, so it's just easier to start with it like this. Oh, okay. Okay, well then I'm thinking how many equations do we have here then?
2 or 3.
2. No, we really only have 2. One of them just has 2 names. One of them just has 2 names. Connor, I'm going to guess that most of us have this one, and Connor just went through the work already of saying, you know what, this would be the smart one to rename for a variable because it has a positive 1 coefficient on the y, right? So if we subtracted 3x right here, would our equation be what Connor and Braden had right there? Would that be what we would get? Yeah. So it's kind of looking to me like our system of equations that we've already renamed Kate's. Might as well use it then. And Joel's is going to stay like it is because we're too lazy to do that one, so why not leave it just like it is? All right. Now what are we going to do? You're going to have to talk loud, whoever's going to talk. Connor?
Plug 20 minus 3x into y.
20 minus 3x is going to go into the other equation for the y. So we're going to, in step 1, we're going to write 2x plus 2y equals 22. And we're going to sub in 20 minus 3x for that y. And everything else in the equation is going to remain as it was. So looks like we're solving for which variable first then? X. We're going to get the cost of a used CD first. So go ahead and make that happen. Find out how much a used CD is going to cost. What'd you guys get? 4.5, okay. So that means then that I can now move on to step 2, which says since you know what x is, why don't you solve for y? Well, we could have that y equals 20 minus 3x. So let's put in our 4.5 for our x. lest you think we can't have a half of a CD or half of a DVD, think again, because we're not trying to figure out the number of them, we're trying to figure out the cost of them. And in step 3 in a word problem, what do? Write a,
System of equations.
no. We don't write an ordered pair, we write a sentence. The cost for a CD is how much? $4.50, because our X was our cost for the CDs, and 4.5 in money means $4.50. And for a DVD is $6.50, because our Y value represented the cost of a used DVD. That's how we write our final answer for the word problem. Whew. Can you do it?
Yeah.
Okay, good to hear. Okay, I'll leave that up there for you for a little bit. Make sure you carefully write down the 9 problems you have to do for tomorrow. And I do not want to have to take papers away or not be able to stamp them again tomorrow because you don't do what we